Hey, what's up? I want to start you off with the first theorem proof right here. Okay, the first theorem that we're going to look at says that if two lines intersect, then they intersect in a point. I drew you a diagram right here. Okay, this is the first of a theorem proof. Now, what you need to remember about theorems is they combine postulates. Okay, so we combine these really simple things that you didn't need to prove into something that you do need to prove. And this is how a mathematical system is developed. Okay, geometry starts with a lot of basic definitions that we kind of just look at, agree upon, and memorize. Then we take those definitions and we combine them into things that are useful, maybe interesting, definitely. Okay, and this is going to be the first theorem proof. Okay. So I've got this diagram right here, and what it shows is two lines. The definition of a line being that it contains at least 2 points and it extends forever in both directions. And a line contains an infinite number of points. Okay. Now line M is right here, and line L is right there. They intersect at point P. This is just a picture. This is actually not part of the proof. Both those lines are contained in plane R. I just wanted to have it up there for you to look at. Now I'm going to pause just for a second because I want to get the proof just right. Okay, so hang tight. Just 1 second. Hey, back. Okay, so we're back with theorem proof number 1. If two lines intersect, they intersect in a point. So I need to prove that statement. Now the cool thing about mathematics is we have a lot of different ways to prove things. Just like if you're going to do it in an argument or talking to somebody to prove a point, there's a lot of different approaches you can take. Now, one of the cool things about learning mathematics is that you learn a logical way to do that. So you don't have to resort to any tricks or subterfuges or try and get by on your charm or good looks or what have you. You learn a logical way to prove something so that there's no doubt that it is the way that it is. And this is a reason to study geometry and proofs in particular. And okay, so let's get into it. What I chose here is a particular kind of proof. We're going to do, it's called proof by contradiction. Don't worry too much about the different types of proof, but check it out if you want to. One little symbol I'm going to chuck in here is a symbol that looks like this: 3 dots and a little pyramid, a little triangle. It's called therefore. Okay, when I write that symbol, it's therefore. In other words, I'm going to say something, and then because of that something, therefore something else happens, or because of it, cause and effect, so to speak. Okay, so check it out. Step number 1, what I'm going to say is A is a point on line L that's not on line M. There's A right there. It's on L and it's not on M. Therefore, my little triangle, L and M are different lines. Okay? Because of the definition of a line, it says that 2 points make a line, and if A isn't on M, then M must be different than L. That's just the way it is. We've defined it. That's what exists. Okay? 2 points make a line. A is not on L or on M, so therefore it must be on a different line. Okay? Now check it out. Third step. P is a point contained by both L and M. Okay? P is contained by both points contained by both L and M. All right, now down here, number 4, I just put a box. That box is what we say, end of proof, end of discussion, it's proven. All right, because P is a point contained by L and M, they share it. Therefore, if 2 lines intersect, they intersect in a point. Okay? In other words, P is a point contained by both of them. They're different lines. They intersect. And when they intersect in 1 point. Only 1 point. And that's it. That's a mathematical proof. Okay. You're going to have to think about it. Proofs are not easy. Okay? And it's something that you have to practice a lot before that you can write a good proof. This year, we're going to study a particular type of proof that's called a deductive reasoning proof. Deductive reasoning. Think Sherlock Holmes. He gets a bunch of facts, and from all those facts, he comes up with a conclusion. Okay? So it goes fact, 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 and therefore fact. Okay, or therefore, conclusion. It's called deductive reasoning, where you reason from what are called premises, these 1, 2, 3. You reason through these premises to a conclusion, which is your black box. Now, an inductive proof actually works backwards. You don't have to worry about that until we cover it, probably in a couple of weeks' time. All right, take care.